Welcome back, students. Hello, how are you, students? Hope all are fine. Hope all are doing well. Hope you have revised all the questions and solved all the questions and assignment and revised all the videos well and done all the assignment questions. Now we are moving on to the next session, students. Okay. This is the part 10 of the video for the topic vectors. Okay, so now we will have a quick review on parallel vectors. Vectors, you know what are parallel vectors, right? Vectors are parallel if they are the same direction. Two vectors are said to be parallel if they are moving the same direction, and then not only that, both the components of the vector, that is if it is a column vector, both components, x component and y components, okay, must be in the same ratio. Okay, now and previous video I spoke to you about position vector also. What is position vector, students? Position vector is a vector in relation, a vector is said to be, it is a position vector is a vector which starts at the origin. That is, a position vector means it is vector is in relation, given is in relation to the origin, is relative to the origin O. Okay, that means a position vector OA gives the position of A relative to its origin O. Origin is represented with O. Okay, that's what I gave you. A position vector is a vector which starts at the origin. Now, students, the position vector of the point A. Here the components, see, the coordinates of A are x and y. So what are the components of vector OA? It will be x component will be x, y component will be y, corresponding to the values it is given. Okay, so position vector of OA is the position of A relative to the origin O. Okay, in this case I am speaking of vector OA. So the position vector of OA gives the position of A, okay, position of A relative to the origin O. Now, vector OA is, I have drawn the vector OA, and if vector OA is 2, 3, position vector of if A coordinates of A are 2 and 3, the position vector OA will be, x component will be 2 and y component will be 3. Okay, the coordinates of A are the components of position vector. That I told you previously with examples also. Now, students, we are going to start with modulus of the vector. Now, what do you mean by modulus of the vector? The length of the vector is called as the modulus of the vector. That is, vector, the modulus of vector, how is it written? Okay, it is written with two vertical bars on either side of the vector. See, magnitude of a vector, or it is also called as the modulus of a vector. So the modulus of a vector represents what? Represents the length of the given vector. And how is it written? It is written with two vertical bars. See, you can see the two vertical bars, okay, on either side of the vector A. See, the magnitude of the vector A is written, or the modulus of the vector A is written as such, that is with two vertical bars on either side of the vector. That's how the magnitude or the modulus of a vector is written. Okay, what do you mean by modulus of a vector? The length of the vector. So the magnitude, the modulus of a vector represents the length of the vector, in this case vector A. Now, magnitude of vector AB, for instance, is written as with two vertical bars on either side of it. Okay. Now, how is modulus of a vector calculated, students? That is very easy, since you already know Pythagoras Theorem. Okay. Now, I told you, if the coordinates of A, column vector, if A, column vector A is xy, components of column vector in this case is given as xy. Okay, and this is an example for modulus of a vector. Okay, then the magnitude or the modulus of vector A will be root of x squared plus y squared. That is using the Pythagoras theorem. This is okay. So using the Pythagoras theorem, you know Pythagoras theorem is applicable in the case of right triangles. You know, this is what type of triangle is a right angle triangle, right? See, so now vector A, the x component and y component. Okay, vector A. Now with the vector A, I have drawn a right triangle, right? Okay, see the x component and y component. So joining the x component and y component, the broken lines shows. Okay, with the broken lines and the vector A, I have given a right triangle. So how do you find the modulus of vector? In the diagram above, vector A is xy. Okay, so by Pythagoras theorem, modulus of vector A is root of, okay, x squared plus y squared, the whole root of x squared plus y squared. That is how you get modulus of a vector by Pythagoras theorem. Okay, now here this is an example question. Express each of the following vectors as a column vector. You have to first express. Here two vectors, I have given two vectors, vector PQ and vector RS. What you should do is express it as a column vector and find its magnitude. Find its magnitude means find the modulus of the vector. First we will deal with vector PQ. Okay, so now you are dealing with the topic modulus of a vector. So when you, after learning this, we will solve questions of exercise 9. Okay, and I will give you assignment questions. Okay, so vector, first we have to write it as a column vector. So you see vector PQ, it is moving. How much has it moved? It has moved 3 up and 2 to the left. So when I told you, when it is left means it represents negative, right? So vector PQ will be -2 and +3. Up means up represents, if it has moved up means it is 3. Y component is 3 and x component is -2 since it has moved 2 to the left. Okay, so vector PQ is -2 and 3. Now we will find its modulus. Okay, so modulus of the vector PQ, how do you find out? You will find root of -2 the whole squared plus 3 squared. Okay, modulus of vector PQ is root of -2 squared, -2 the whole squared plus 3 squared, that is root of 13 units. Here I have written root 13 units. Why, students? See, you can and now students, you can open your textbook also, please. Open your textbook, page 275. All of you students, please open your textbook, page 275. Okay, exercise 9. There the question, in the question exercise 9, they say that find the following leaving the answer in square root form where necessary. That means you can leave this answer in square root form. You are not necessary to simplify it. Okay, you can leave the answer in square root form. Okay, so that is why I left it here in square root form. Now we will go to the next question, that is vector RS. Now what is the components of vector RS, students? See, it has moved to the right 5. And what is the vertical movement? Vertical movement is 0. So what is the x component is 4. See, it has moved 4 to the right. Okay, and vertical component I told you is 0. So vector RS is 4, 0. X component is 4 and 0, because x component shows movement to the right or to the left. Here it is 4 to the right, so 4. And I told you vertical movement, it hasn't moved vertical movement, so vertical movement is 0. Okay. Now we will find modulus of vector RS. That will be root of 4 squared plus 0 squared. It will be 4 units. Okay. Okay. So root of 16 you will get 4 units. Now next is, students, see, finding the magnitude of a vector at the origin. Now here I will describe to you how to finding the modulus of the vector with a graph sheet. Okay, here I have given the coordinates of vector of v. Coordinates of v are 3 and -5. Okay, I have marked here. Now I will join it. Okay. Okay, here from the origin I have drawn the line. Okay, so 3 and -5. okay, from the origin. Okay, x coordinate is 3 and y coordinate is -5, so it will come here. So I have joined. Okay, now finding the magnitude of a vector at the origin. Now we are going to find out the magnitude of a vector at the origin. Here, determine the components of the vector. What I have given here, I have given a note here. See, first what you do is you determine the components of the vector. That is, each in the graph means each vector can be numerically represented, right? With the in the Cartesian coordinate. This is a Cartesian coordinate with the horizontal x-axis and a y-axis. And what is the ordered pair for this, for the v? The ordered pair is 3 and 5. Okay, the ordered pairs of this v is 3 and -5. 3 shows the x coordinate and -5 is a y coordinate. Okay, it is written as an x ordered pair in the Cartesian coordinate. So every vector can be numerically represented in the Cartesian coordinate. Okay, this is a Cartesian coordinate or the graph or the plane with the horizontal x-axis and the y-axis component, and it is written within as an ordered pair. Okay, that is x coordinate and the y coordinate. Now, for in this example, the vector above has a horizontal component. Okay, this vector here has a horizontal component of 3 and a vertical component of 5. Okay, horizontal component of 3 and vertical component of -5. Therefore, the ordered pair is 3 and -5. Now, we will go to modulus of a vector. To find modulus of a vector, you know, I told you, it is, you are going to apply Pythagoras theorem, right? And Pythagoras theorem is applied in the case of right angle triangle. So, draw a vector triangle, students, here. Okay. Now, when you draw the horizontal and vertical components, you end up with a right triangle. I told you about the horizontal and vertical components, right? Horizontal component is -3 and was 3 and -5 vertical component. So I have got a triangle, right angle triangle. So I have drawn here a right angle triangle, just a Pythagoras theorem. Okay, right angle triangle showing to explain the Pythagoras theorem. Okay, so according to the Pythagoras theorem, this is a review also on the Pythagoras theorem. Okay, Pythagoras theorem, it states that hypotenuse squared is equal to the sum of the square of the other two sides. So c squared, that is, here c represents the hypotenuse. Hypotenuse means what? It is the longest side opposite to the right angle. Okay, this is a right angle. So, and hypotenuse is the longest side of a right angle triangle, and it is always opposite to the right angle. Okay, so the hypotenuse squared is equal to the sum of the square of the other two sides. That is what the Pythagoras theorem says. Here A is the x and B is the y, and C represents the v. That is as per the previous question example. So what you should find out is the C, that is hypotenuse, that is v. Here we are representing it as v because in our question, that was the question was v. Okay, v squared is equal to x squared plus y squared. So what is v? V is equal to root of x squared plus y squared. That's how you, that's the case of Pythagoras theorem. So this is what you are going to apply for the question. Okay, so with our question, Pythagoras theorem is a squared plus b squared is equal to c squared. Okay, and a and b are the horizontal components. This I already told you, and a and b are horizontal components. Okay, and vertical components of the triangle. Well, C I told you is a hypotenuse. Here in that case I told you C represents v. So since the vector is a hypotenuse, we will solve for v. So root of x squared plus y squared. What is x, students? In our question was 3 and y represents 5. Okay, so substitute the values. So we will get 9 square, 9, 3 squared is 9 plus -5 squared is 25. So root of 34. Here I have simplified and given, but as per your question in the textbook, you can write it in root form, answer in square root form wherever necessary. Okay. So this is how you do modulus of a vector. Now students, we will move on to vectors in vector geometry. Okay, so with modulus of a vector, I hope all of you have understood modulus of a vector. We have done the example question, and that's how you are going to solve the textbook questions. Okay, exercise 9 questions. Okay, so modulus of a vector, to find modulus of a vector, what you do is apply the Pythagoras theorem. That is, the hypotenuse squared is equals to the sum of the square of the other two sides. Okay. In this case, use the horizontal component and the vertical components. So, okay, horizontal and the vertical components of the triangle are used, okay, to find out the modulus of the vector. So, since the vector is hypotenuse, you want to solve for C. Okay, so here what did we do? We substituted the horizontal and the vertical components to find out the modulus of the vector. So, modulus of vector represents the length of the vector. Okay, now is written with two bars on either side of the vector. Now we will move on to vector geometry, students. Okay, so speaking about vector geometry, now students, we will speak about vectors in geometry. Okay, vectors in geometry, you know, from the beginning I told you, in geometry vectors are described using capital letters. Okay, vectors in geometric problems involving vectors can be written using a pair of capital letters with an arrow above them. Okay, that's how it is described here. Now, for example, in the diagram below. Okay, now vector rs is described using the term A, and vector pq is described using the term 2a. Likewise, vector sq is described using the term B. Now we will see the relationships. Okay, now what type of figure is this, students? This is a trapezium, and you know the property of trapezium, right? One of the pair of opposite side, one of the pair of sides of trapezium are parallel, right? So here vector pq and vector rs are parallel. Okay, so one pair of opposite sides are parallel. That is a one of the property of trapezium. Okay, now vector rs is A. So what is vector SR? With reference to vector rs, vector SR will be in the opposite direction. So it can be described as negative A. Okay, see, vector rs is A and vector SR is negative, because with reference to positive vector rs, vector SR is in the opposite direction. So it will be negative A. Likewise, speaking about vector PQ. Vector PQ is 2A. With reference to vector PQ, vector QP will be in the opposite direction and can be described as negative 2A. Okay, now here this is an example of a students, we describing vectors using terms we have done in the beginning. So now we are starting vectors in geometry. So this question will help you to reminisce what we have learned in the basics of geometry, vectors in the initial stage. Okay, now the next is vector SQ. Vector SQ is B. So what about vector QS? Vector QS with reference to positive vector SQ is in the opposite direction, so it will be described as negative B. Okay, now this relationship of there is a relation between vector PQ, okay, and vector rs. Okay, see, vector PQ equals to 2rs. That means vector rs is half of vector PQ. Okay, see, you should understand this relation. See here, that is why especially I took this exam question with trapezium as so to explain for you first beginning itself for vectors in geometry, because here this relationship you need this relationship between two vectors. You need to understand for further solving the questions in exercise 9. Okay, and exercise 10. Okay, now vector PQ. Vector PQ is equal to vector 2 vector rs. That means vector rs is equal to half of vector PQ. Okay, that is vector PQ is double of vector rs. So vector RP can be written in terms of A and B by taking a known root, and for solving vectors you always have to go via known roots. Okay, take a root of known vectors from R to arrive at P. Okay, so from R to P it will be vector rs plus vector SQ plus vector QP. Okay, the rule of vectors is go via root of known vectors. So vector RP is going to be, see, I have drawn vector highlighted vector RP with the blue. So you will know what is vector RP. So to get vector RP, the rule of vectors is go via root of known vectors. Okay, so what you know is A plus vector, that is, you will now, which direction is this going to move? Anti-clockwise. Okay, going anti-clockwise around the diagram will give you vector RP. So vector RS is going to be A plus, I told you already, vector RP is vector RS, that is A, plus vector SQ, that is B plus B, plus vector QP, that is negative 2A. Vector QP is negative 2A. Why? Because with reference to positive vector PQ, vector QP is negative 2A. Now you will simplify. A plus B minus 2A. So group the like terms. A minus 2A, that is 1 minus 2, it is minus A. Okay, as per the rule of integers, it takes the sign of the bigger value, so negative 2. So here negative A, B minus A. Okay students. Now again, speaking of vectors in geometry, we will see to the next type of quadrilateral. Okay, the following diagram below is a parallelogram ABCD. Okay, in vectors in geometry, for your topic vectors in geometry, you have different types of figures, from parallelogram, trapezium, then hexagon, different types. Okay, triangles. Okay, all comes under vectors, and you have to find out the vectors for the given whichever question is asked. Okay, now in this question it is a parallelogram. The diagram below is a parallelogram ABCD. Okay, write the following vectors in terms of P and Q. And hope students, all of you revise the properties of parallelogram which we discussed in detail in the last video. Okay, all of you revised, right? Okay, now we will, this is in the following question, write the following vectors in terms of P and Q. Vector AB is described as P using the term P, and vector CB, okay, vector CB is described using the term Q. Okay, see, I read it as vector CB because the arrowhead, okay, arrowhead, the point, direction of the arrow tells us the direction of the vector. See, so it is vector CB. Vector CB is described using the term Q. Now, first question is vector dA. Vector dA. What is vector dA, students? You know the property of parallelogram, right? So, as per the property of parallelogram, you learned, I told you, opposite sides of a parallelogram are congruent. Congruent means they are of equal size and they are in the same direction. Okay, that is, they are parallel and they are both, the opposite sides are parallel and they are both opposite sides are equal, that is, they are congruent. Parallel, you know the meaning of parallel, right? Two lines are said to be parallel if both the two lines are moving in the same direction and they keep same distance apart. Okay, that is how you define parallel. I told you that previously in the one of my video, I'm sure of that. Now again, coming back to a question here, you have to describe vector dA in terms of P and Q. Okay, now vector dA, okay, to find vector dA, you should remember the property of parallelogram, that is, the side dA and side CB of the parallelogram are congruent, right? Right? Because as per the property of parallelogram, opposite sides of a parallelogram are congruent. That means the side dA and side CB are equal. They are in the same direction and they are of same size. They are equal. Okay? So, if vector, so that I told you, so in relation to vectors, if vector CB is described as Q, okay, then vector dA can also be described as Q. Okay, and you know the rule of vectors is you always have to go via root of known vectors. So vector dA is going to be Q because opposite sides are parallel and are equal in length. That is the property. This is the property, one of the property of parallelograms. Okay. Now we will speak about vector CD. Vector CD. This is vector CD. Okay. Now vector CD with reference to vector AB. I told you previously, opposite sides of a parallelogram are parallel and are equal in length. That means the side AB and side DC are parallel, right? They are equal in length and they are parallel. So with reference to their relationship of parallelogram with vectors, okay, speaking about vector AB, which is described as P, vector CD will be in the opposite direction, so it will be described as negative P, because okay, it is in the opposite direction with reference to vector CD is in the opposite direction with reference to vector AB. Okay, and why we chose P? Because opposite sides are parallel and equal in length for a parallelogram. Now we will speak about vector DB. What is vector DB? See, I will draw and show you. Vector DB. This is vector DB. What is vector DB? That is a diagonal of the parallelogram. Okay. See, I have drawn the vector DB. See. Now, vector DB is going to be, you have to go via known roots, right? Vector DB will be vector DC plus vector CB. Vector DC is what? Q. And vector CB is Q. Vector DB is what? Q. Vector DC is, the vector DC is P. Students, see, vector AB and vector DC are both equal, right? So that means vector AB is P means vector DC is P. Okay. And vector CB is Q. So Q plus P. That is, when you, P plus Q or Q plus P, both are the same. Okay, it can be either P plus Q or it can be either Q plus P. That is what I have given here. It will be Q plus P when you go via A, and it will be P plus Q when you go via C. That's what I told you at the beginning. It can be either P plus Q or Q plus P, because for vectors you can go via root of known vectors. In this case, you know all the four sides of the given parallelogram, of the given figure parallelogram. Okay, because of the property of parallelogram. Since you know the property of parallelogram, you know all the sides of vector sides. You know how all these vectors are described. Okay. Now we will go to vector AC. What is vector AC, students? Vector AC means from A to C. That will be, I will draw and show you. Vector AC will be vector, that is also the diagonal of the parallelogram. That so this is the diagonal I have drawn, vector AC. See, it is from A to C. Okay. Now vector AC will be also what? P plus negative Q, or it will be P plus negative Q. It can be written in both ways. Here, as I showed you, both ways I will write and show you. It can go via B or go via D. Okay. Okay. See, P minus Q or minus Q plus P. Here, this is going via B, it will be P minus Q. P minus Q. Okay, by Q, P by negative Q, because vector BC is with reference to vector BC, vector CB will be in the opposite direction. So to vector AC will be vector AB plus vector BC, and vector BC with reference to vector CB is in the opposite direction. So it will be negative Q. Okay. And equivalently going via D, if you are going via D, that is, you need vector AC. So if you are going via D, it will be what? Negative Q, because vector AD with reference to vector BC is in the opposite direction. So it will be negative Q plus vector DC, that is plus P. Okay, anyway both your answers are the same. See, the values are the same, right? P plus negative Q or negative q plus p, both are the same. Now we will speak about vector C. That is the fifth part of the question, vector CA. Now vector CA. Vector CA is what? Opposite of vector AC, right? Because you know vector AC already. So vector CA will be is in the opposite direction to vector AC. Okay? Okay, so now it will be negative of AC. See, I have drawn it with red line. Okay, see, you can see this red arrow indicates opposite direction with reference to vector AC. So with reference to positive vector, with reference to vector AC, vector CA is in the opposite direction. So it will be negative of vector AC. So negative of vector P minus Q. Okay, so you know the rule of negative. When you take the negative of vectors, what happens? I told you, both the component signs will change. So it will become Q minus P, or else you remove the brackets. Okay, negative, and here the value the P is positive. So negative, when you remove the bracket, it become positive. Negative multiplied by positive is negative P, and negative multiplied by negative is positive. Okay, positive Q. So vector CA you got. Vector CA, in other words, is negative of vector AC, because with reference to vector AC, vector CA is in the opposite direction. That is why I have given it with red arrow. Okay, students. Now we will go to the next question. Okay. The diagram below is an hexagon. This is the next type of geometry. For the vectors in geometry, you have different types of figures. I told you. Now we discussed about two types of figures. That is, first was trapezium. The second is parallelogram. Now we are coming to an hexagon. Example of an hexagon figure, so that you will be familiar with all the questions related to hexagon also. Okay. See now, students, the diagram below is an hexagon. What's the name of the hexagon? Hexagon A, B, C, D, E, F. Okay. Now, seeing at the diagram, do you think it's a regular hexagon, students? What do you mean by regular? The word regular, I told you previously, when you see the word regular itself, I told you should understand that it denotes all the sides are equal. Regular polygon. What do you mean by regular polygon? Regular polygon means all the sides of the corresponding polygon are equal. In this case, this is a regular, not a regular hexagon. That means all the sides are not equal. See, all the sides are not equal. Okay. So, regular hexagon, I dealt with you for another question for regular hexagon, remember. But this case is not of a regular hexagon. All the sides are different. Now, write the following vectors in terms of A and B. Now, vector AB. Vector AB is what? Described using the term A. Vector BC is described using the term B. Vector ED is described using the term 3A. And vector FE is described using the term B. Likewise, vector FC is described using the term F4A. Now, vector AC. We will see about first question is vector AC. See, always the rule of vectors is you have to go via root of known vectors. So, first question is vector AC. Okay, students. Now, I will draw for you vector AC. Okay. See, I have drawn vector AC with the blue arrow. Okay. Showing that it is from A to C. So, as per the rule of vectors, you have to go via root of known vectors. So, vector AC is going to be vector AB plus vector BC. That is A plus B. Okay. So, A plus B. That is vector AC. Now, vector FA. FA. Okay. That also will be, you have to go via the known roots. So, that will be vector FA will be vector FC plus vector CB plus vector BA. Now what is vector FC? That is 4A. It's already given to you. Plus vector CB. Vector CB with reference to vector BC is in the opposite direction, so it will be negative B. Likewise, vector BA is in the opposite direction to vector AB, so it will be negative A. So now you will simplify the like term, students. 4A and negative A, it becomes 3A and negative B. Okay, 3A minus B, that is the answer. 4A vector FA. Okay, 4 minus 1. Near the coefficient of A is 1. Coefficient means what? The numerical value. Okay, so the numerical value of A is 1. For 4A minus A is 3A minus 1. Now we will go to the next question is, next part of the question, that is vector FD. Now vector FD, see here, this is vector FD, means from F to D. Okay, so we will see how we will move. Okay, FD, you know already FA, right? But yeah, the FD is very easy actually. See, you can move as the node roots. Vector FD is going to be, see, I have drawn vector FD. Okay, F to D. So here it will be F to D, that is B plus 3A you can take. Okay, that is already given to you, B plus 3A. FD I have drawn with blue arrow. Okay, now students, we will go to vector DC. Vector DC. Vector DC means from D to C. Okay, vector DC, here this side, this vector DC, you have to go via the known roots. So that will be vector FD, you already know. So that you can use for finding out vector DC. So vector DC is going to be vector DF plus vector FC. Okay, see, vector FD you already found out, so you apply that value first. Okay, that will be negative 3A. Here you have already found out, right? Vector FD you already found out, B plus 3A. Now what about vector DF with reference to vector FD? Vector DF will be in the opposite direction, so the values will be, the terms will be negative. So it will be negative 3A and positive B becomes negative B. Here positive 3A becomes negative 3A because vector DF, vector DC, what is vector, how is this vector DC described? Vector DC means vector DF to vector FC. Okay, you have to go via route of known vectors. Okay, you can go through this also, students, vector DE plus vector EF plus vector FC. That only we already found out. Okay, negative 3A, negative B, okay, vector DC. Okay, so like that case also it is the same thing. See, vector D is negative 3A because with reference to vector ED, vector DE is opposite direction, so it will be negative 3A. Okay, and vector EF with reference to vector FE, vector EF is negative B, so it will be negative B plus vector FC. Okay, plus 4A. So vector DC is going to be vector DE plus vector EF plus vector FC. So vector 3A, so when you add all these vectors together, that is the vectors are described using terms. So vector DE is negative, described as negative 3A. I told you how you got negative 3A. It is the opposite direction vector ED. Okay, so negative 3A. I explained to you in detail about negative vectors, so that is why I did not show you here. It's all here. You can see here vector ED is 3A, so it will be vector DE is opposite of vector ED, so it will be negative 3A. Okay, so negative 3A plus 4A, you will get A minus B. Okay, because here group the like terms, negative 3 and negative 3A and positive 4A. These are the like terms. So negative 3A and positive 4A you will get A. Just apply the rule of integers. Okay, for addition and subtraction of integers. rules of addition or rules of addition and subtraction of integers. Okay, so negative 3 and positive 4, you will get positive a. Now going to next part of the question, students, vector AE. Yeah, this is vector AE. So I'll draw the line for you, students. Vector AE, so that you can know. See, I have drawn vector A with a blue arrow showing that it is from A to E. Okay, so what is vector AE? AE will be vector AF plus vector FE. Okay, vector AE is going to be vector AF plus vector FE. Vector AF. What is vector AF, students? You found out vector FA, right? See, they have asked you vector FA. You found out vector FA. So, vector with reference to vector FA, vector AF is in the opposite direction. So, vector FA is 3A minus B. So, vector FA will be negative of vector FA. So, that will be, the terms will be, the signs of the terms will change. So, that will be negative 3A and positive B. Okay. So, that is, here I have shown you vector AF with reference to vector FA is the opposite direction. So, to get vector AF, it will be negative of vector FA plus B. Vector AE is going to be vector AF plus FE. Vector FE is B. Okay. Vector FE is B. That I have written here, B. Now, what about vector AF? Vector AF is negative of vector FA. Negative of FA. So, that will be negative of this term. Negative of 3A minus 3A minus B. So, this 3A is positive. So, it will become negative, and B is becomes negative multiplied by negative, it becomes positive. So, negative 3A plus B, when I remove the bracket, students. So, negative multiplied by negative, you will get positive B. So, now group the like terms, B plus B, you will get 2B. 2B minus 3. Okay. Now, students, here I have given the nexus. We dealt with hexagon previously, but was not a regular hexagon. Okay, last slide I showed you about an hexagon, but that was not a regular hexagon. Now we will see with regular hexagons. Okay, the diagram below is a regular hexagon A, B, C, D, E, F. Okay, write the following vectors in terms of A and B. Okay, you know the difference between vector regular and irregular, right? I told you previously. Now vector FC. They are asking you for vector FC. Here always apply the rule of vectors is go by root of known vectors. You know vector AB. And that means for regular hexagon, I gave you the relationship between hexagon and vectors. Remember? Here for regular hexagon, okay, opposite sides of a regular hexagon are parallel. Remember this rule I gave you, opposite sides of a regular hexagon are parallel. So here vector AB and vector ED are parallel. Opposite sides, these are opposite sides. Okay, vector side AB is opposite of side ED, is opposite to side ED. So opposite sides of a regular hexagon are parallel. So vector AB and vector ED are equal. So, vector FC, what is vector FC? Vector FC is going to be 2A. Okay, that is here. I told you the property, remember, vector here. How did you get 2A? Remember this, students, this vector AB and vector FO. Remember the diagonals property, okay? The diagonal of a, here this diagonal vector AB and the diagonal FC are parallel. So, if this is A, then vector diagonal FC is double of vector, double of side AB. That is a property of hexagons. Remember I gave you in detail we're in the relationships, that is why it is 2a. Okay, here AB is A, so FC is going to be 2a, because with reference to side AB, the diagonal FC is double of side AB. So it will be A plus A, which is going to be 2a. Now we will see vector dA. dA is, see, vector dA means from D to A. Okay, so it will be with reference to side BC, diagonal DA, okay, both side BC and diagonal AD are parallel. Okay, but here they are speaking about vector dA. So you need vector dA means it is going to be in the opposite direction. So it will be if vector BC is B, vector DO, diagonal, see these two diagonal, the side BC and diagonal AD are parallel. Okay, so that means this diagonal AD is double of side BC as per the rule of hexagon. So in this case you need vector dA. So vector dA is in the opposite direction to vector BC. So it will be negative 2b. Negative b plus negative b, it will be negative 2b. Now students, we will speak about vector EB. Vector EB, I will show you. Vector EB, this is vector EB. Vector EB means vector EF plus vector FO plus vector OA plus vector AB to get vector EB. Why we are going like that? Because we have to go via known roots only. Do you know vector? See, vector EB. Vector EB will be vector EF plus vector FO plus OA plus vector AB. Okay, so I'll write the values and show you. Vector EB is going to be negative B, because this is with side BC and side FE are opposite sides of hexagon are parallel, right? So vector BC, side BC and side FE are parallel. That means they are in the same direction, they are equal because it is regular hexagon. So if side BC is described as B, then side FE is also described as B. So now vector BC is described as B. That means vector FE can be described as B. But vector EB means you need to go from E to B. That will be EF. EF is opposite direction to vector BC. So that is why vector BC is B. Vector EF will be negative B. Okay. Now, then again vector FO. Okay. Vector FO is, you already know, that is A. Okay. Vector FO you already know. Even we found out vector FC. This is a diagonal FC. So with reference to side AB, this is double of side AB. So FO is A. Then plus OA. OA is negative B, because this is BC, the side BC and the diagonal AD are parallel. So if this is B, this is also AO is B and OD is also B. That is why vector dA is negative 2B, vector dA. Okay, so OA is negative B because vector BC is in the opposite direction to vector OA. So it is negative B. Okay, plus vector AB, which is positive A. Okay, so now what are you going to simplify, and you get 2 negatives and 2 positives. You will simplify to get 2a minus 2b, which you can further simplify. Take out the common term, common value, common factor here is 2. So you take out the common factor 2. What is remaining is a minus b. 2 multiplied by a minus b. Okay. 2 multiplied the a minus b the whole multiplied by 2. Okay, now we will see to the next vector, vector EA. Okay, we went through this why because we have to go via the known roots only. That is why we went like this. Okay, to find vector EB, we went from EF plus F4 plus OA plus AB. Okay, because we don't know vector AF, but in one of the video for regular hexagons, I taught you how to find this vector AF also. But in this question, we don't need to find out and waste our time. Okay, because we know some of the vectors, so go via the known roots. That is why especially I chose this question as an so that you can deal with both types of hexagon questions. Okay, regular hexagon, regular hexagon. So to find out the unknown also I have taught to you. So almost all the types we are dealing with. So whichever type of vector geometrical questions asked, you should be able to solve, because I am dealing with all the types of figures now. We dealt with trapezium, parallelogram, hexagon, regular as well as irregular. Okay, and hexagon also I told you the relationship, parallelogram I told you the relationship, and hexagon I told you how to find the unknown side vector for unknown side also here, but we do not find out because that without finding that also we can move on to find the vector value. Okay, we can describe vector without knowing the vector FA. Okay, also we can find out in this method. So you should know both methods. That is why both ways you should know. However the question is asked, you should be able to solve the question. That is why I have chosen this question especially. Okay, some of the exercise questions I'll give you as homework also, students. So now since you are familiar with all the type of figures, all the types of quadrilaterals and polygons, different types of polygons, you will be able to solve the different types of questions of whichever question is asked you. Now we will go to the next part of the question, vector EA. See, I have drawn with blue arrow, students, vector EA. Okay, vector EA I have drawn with blue arrows. See the direction of the vector, students. Now arrowhead shows the direction of the vector. Okay, vector EA means vector, you will go by the known roots only. Okay, so vector EA is going to be vector EB minus A. Okay, vector EB. Do you know vector EB? We already found out vector EB, students. See, minus A. So you to find any vector, you have to go via root of known vectors. So to find AE, you can go take vector EB minus vector A, vector BA, that is minus A. Okay, so vector EB is what? You already found out 2A minus 2B. You already found out here. So vector EA is going to be, we will simplify the values, students. So here it will be 2A minus A, it will be A minus 2B. Okay, 2A minus A, it will be A, and 2B minus 2B. Now speaking of vector FD. Okay, so remember, go via root of known vectors only. Okay, that is why we took EB now, vector EB minus vector BA. Vector EAB is A with reference to vector AB, vector BA is negative A. Will be described using the term negative A. Now we will see vector FD. FD. Okay, I'll draw and show you where is vector FD. Okay. Now vector FD means you will go from vector FE plus ED, because you know vector FE, right? FE and vector FE and vector BC. See, the side BC of the hexagon and side FE are opposite. So opposite sides of hexagon are, regular hexagon are parallel. See, remember I taught you, and here I have given as a reminder also. Opposite sides of regular hexagon are parallel. So side BC is parallel to side FE. Okay, so that means if side vector BC is described as using the term B, vector FE also can be described using the term B. Now what about vector ED? Side ED and side AB are of the regular hexagon ABCDEF are parallel. So if vector AB, is described as term using A, then vector ED can also be described as A. So vector FD, okay, I have shown with blue arrow, go via the known root. So vector FD will be FE plus ED, that is B plus E. Okay students, now go to the next question. Okay, here it's a trapezium given to you, but there is a, here in this question there is a midpoint of AB is given to you. Okay, see the diagram below shows a trapezium ABCD with M as the midpoint of AB. M as the midpoint of AB, okay. Write the following vectors in terms of P and Q. You have to write the following vectors in terms of P and Q. M as a midpoint of vector of the side AB. Okay, in the diagram below shows a trapezium ABCD and M is the midpoint of AB, of side AB. Now students, we will speak about vector AD. Vector AD. AD means from A to D. You know you have to go via known roots only. So vector AD will be from AB plus vector AB plus vector BC plus vector CD. Okay, so I'll write and show you that. That will be 4P plus negative Q plus negative P. Okay, because why negative Q and negative P? Because BC, vector BC will be in the opposite direction to vector CB. So if vector CB is Q, it will be vector BC is negative Q. Okay, and vector CD is negative P. Okay, 3P minus Q. Okay, that is 4P minus Q. P will be 3P minus Q. Okay, so 3P minus Q. Now the next question is vector CA. Vector CA means from C to A, students. Okay, here also you will go via the known roots. You know already vector AD, right? So you can use that. Okay, vector AD will be, vector CA. Vector CA will be vector CD, that is CDP. Okay, CA. Okay, C to A, that is Q. Yeah, vector C. CA will be vector CB, that is Q already given to you. We can move like this. Vector CB plus vector BA. Vector BAB is already given to you, students. What is vector AB? Vector AB is 4P. Okay, so with reference to vector AB, vector BA is in the opposite direction. So it will be negative 4P. Okay, so Q minus 4P. Vector CA will be Q minus 4P. Okay, so here vector CA also you found out Q minus 4P. Now the next is, here speaking about this vector CA, you can go like this also, students. CD plus vector DA. In both cases your answer will be the same. Okay, now we have gone through this. That is Q plus vector CB, that is Q, plus vector BA, that is negative 4P. Okay, now we will go to vector DB. Vector DB, I will draw and show you that, students. Vector DB, I will draw and show to you. That will be, okay, see I have drawn with the blue arrow vector DB. Okay, the blue arrow shows vector DB. Now we will find out vector DB. Vector DBC you can find out easily because you know vector DC and vector CB. Okay, so that will be P plus Q, vector DB. Now we will speak about vector CM. Where is CM? Yeah, C to M. That means I have to draw here a line from C to M. I will draw that and show you. C to M. And what is M? M is a midpoint, right? Yeah, see, M is a midpoint of AB, of side AB. M is a midpoint of side AB. So we have to join C to M. So to find vector CM, I will draw the line, students. See, I have drawn that with red arrow. So vector CM, right? So we will see. So vector CM will be vector CB plus vector BM. Okay. So vector CM is going to be Q minus 2P. Is it because this is Q? Vector CB is Q, right? Plus vector BM. What is vector BM? Vector BM, vector AB is 4P. See, it is given as 4P. So vector MB will be half of vector AB. So that will be 2P. But BM means it's the opposite direction. So it will be negative 2P. Okay. That you can easily understand, students. You are level 9. You can easily understand. You should, by now, since we have solved so many questions, you should know that easily. Okay. Okay, and for IG, multiple steps for these simple these questions, multiple steps are not asked, required. You have to solve it and write it in the simplest form. That's it. Okay, so it is Q minus 2P. Okay, you know how you got 2P, right? That is BM, negative 2P. 2P. Then next is, students, we will see about. Next question is vector. Here we'll move on to the next question, vector MD. Okay, vector MD I have drawn for you. See, students, vector MD I have drawn using a green arrow. Okay, so this is vector MD. Now this in vector MD means from M to D, right? So we will find out vector MD. Now vector MD means from, it will be, we can move into both ways, we can move, both directions we can move. Okay, we will find out, go through the easy way. However you move, it will be the same answer. Vector MD, right? MD is going to be vector MA, that is 2P. Since vector MB is MB, I already told you how you got 2P. See, likewise MA is going to be negative 2P plus vector AD. Vector AD is how much? You found out here. Okay, vector AD. Vector AD is 3P minus Q. That is going to be, see, 3P minus Q. Vector AD is 3P minus Q. So that will be negative 2P plus 3P minus Q is going to be P minus Q. When you group the like terms, students, negative 2P plus 3P is going to be Q. Negative 2P plus 3P is going to be P. Okay. So negative 2 and positive 3, you will get P, negative Q. Okay, so your answer is P minus Q. Now students, this is a ratio type question in triangle ABC. Okay, P is a point on AC. P is a point on AC such that CP is to PA, such that CP is to PA is equals to 3:1. Find BP. Find BP in terms of M and N. You have to find BP, okay? That means you need to draw a line from here to join B to P, okay? See, in triangle ABC, P is a point on AC. On AC such that CP is to PA is 3:1. That means if this line AC is divided into 4 equal parts, CP is going to be 3/4, 3 out of the 4 parts, and PA is going to be 1 out of the 4 parts. Okay, so now we will see, find vector BP in terms of M and N. In terms of M and N. Now I will draw the line, students. Okay, I have drawn with blue arrow showing vector BP. Okay, vector BP. I have joined B to P. Okay, drawn the vector BP with blue arrow. Now we will find out vector BP. Vector BP is going to be, vector M is already given to you. Now what is vector CA, students? Vector CA is going to be vector CB plus MA, right? That is CB is N plus M. Okay, vector CA you know is N plus M. So since you know vector CA, you can easily find out CP. You know how you got CA, right? N plus M. That is N plus M, CB plus MA. Now, vector CP is going to be this M, okay, vector BA plus 3/4 of vector CA. That is B. You need BP, right? Okay. Students, you are going to find BP. Now we will find CP. Okay. You can go in the other way also, AP also. We will move on to this way. Okay. So vector BP is going to be, first we will find CP for that. Vector CP is what I told you already. Vector CP is 3/4 of CA, right? 3/4 CA. That is if total CA AC, the line AC is divided into 4 equal parts, CP is 3/4 of the total. 3/4 of CA. That's what I told you. Okay, 3/4 of CA. So 3/4 of CA means what is vector CA? Vector CA is n plus m. Vector CA is n plus m. So 3/4 of n plus m. So here the term I have substituted here the terms of vector CA. So 3/4 of n plus m to find vector CP. Okay. Now find BP in terms of m and n. Now students, you know, first we found out vector CA. Now from vector CA, I told you from in the beginning is what about vector CP and PA. So if vector CP is 3/4 of CA, vector PA is how much? 1/4 of CA, right? Yeah, it will be 1/4 of CA. Now vector BP is going to be, when we move in this way, you can move in this way also. For that you will find vector AP. Vector AP will be what? 1/4 of CA. Okay, now I am going in this direction. Either way you can move. Vector BC is going to be negative n. Okay, plus 3/4 of n plus m. Here 3/4 of CA. 3/4 vector CA. Vectors 3/4 of this total. Okay, so that is vector CP. So BP vector BP is going to be vector BC plus 3/4 of vector CA. So what is 3/4 of vector CA? 3/4 of vector CA only is vector CP. So in other words, I can say vector BP is going to be vector BC plus vector CP. Okay. So vector CP you already found out here. So negative n plus 3/4 of CA. That is n plus m. That is CA is n plus m. Now you will simplify it. Students, you will remove the brackets. Here it is, see, the n is negative, right? And this is 3/4 n. So this 1 n, the coefficient is 1, right? So you can simplify here itself without taking any LCM. You can simplify 1 minus 3/4. Okay, it will be negative 1/4. Okay, plus 3/4 n. Because here it is 1, right? Coefficient is 1, negative 1. Okay, and so you will get negative 1/4 plus 3/4 m. Okay, 3/4 n plus 3/4 m. So that is, so you have expressed, right, BP in terms of m and n. That's what is given here. So these are some of the vectors showing some relationships. Okay, students. Here again, as Paji, you can write it in this form also, no problem. Here again I have taken out the common factor. I have written the common is 1/4 of 3m, 1/4 of 3m minus n. 1/4 of 3m minus n. Write it in that way also. Okay. Okay, these are some of the questions for you students. Now again, so I hope all of you have done well, and go practice all these questions, students. Now I will give you, moving on to the next session, I will give you some assignment questions also from this topics, vectors and modulus of a vector. Okay, students. Now students, I will give you some assignment questions. These are some assignment questions for your for you. This is from exercise 9, question 2, 7, 14 and 17 A and B. Okay, exercise 9, question 2, 7. These are the assignment questions from exercise 9. Now I have introduced to you vector geometry also, that is coming in exercise 10. So that I have given you many questions already. We have solved many questions of exercise for vector geometry also. So now this is the over questions for question 2, 7, the questions from exercise 9, question 2, 7, 14, 17, A and B. Okay, these questions, do practice it, revise everything. Bye, see you, study well, take care.